Okay, so guys, today what we're doing, the plan is to go through 4.7. And so 4.7, y'all, talks about these things called inverse trig functions. And so what an inverse function does is it does the opposite, okay? So, um, for instance, if I were to ask you, let's see, let me get my pencil going, see if it works today. This thing is always messing up. I think I have another battery. Let me try that. I think I do. I thought I did. This is not what it's supposed to be. Better. Okay. So the idea behind inverse trig functions, guys, is suppose I told you that the sine of my angle was, suppose I told you the sine of my angle was equal to 1, okay? Could you tell me what angle would I have to take the sine of so that I would get 1? Anybody know? When is the sine equal to 1? Anybody? So remember we talked about our 5 main points, right? So we had 0, we had pi over 2, we had pi, we had 3 pi over 2, and we had 2 pi. My question to you is, do you remember the sine of what angle gave me 1? 90 degrees, right? Or pi over 2, okay? So what we do is we say, well, theta is the inverse sine of 1. This is the idea, this little power of -1 gal. That's the idea of doing the inverse. So if I told you that the sine of my angle was equal to a certain number, the question would be, what was that? What did that angle have to be so that when we took the sine of it, we came up with one, right? Okay. So guys, this little symbol right here, the way we read that is sine inverse. Okay. Now, I'm going to come back. I'm going to look at the regular notes in a little bit, but I'm going to ask you another problem. The sine of my angle is equal to 0. What angle did we have to take the sine of so that we got 0? Anybody know? So think about it again. Think about it this way. Remember, we're talking about those 5 points, right? 0 degree or 0, pi over 2, pi, 3 pi over 2, 2 pi. Or in degrees, 0, 90, 180, 270, 360. When is the sine equal to 0? I'm sorry? It would be 0 or 2 pi, right? Now, guys, there's something called, when we're dealing with 0 degrees, or we could even just put 0, but we can also put 2 pi, right? So the idea here, though, is when we're dealing with functions, and you might remember this from college algebra, maybe you do, maybe you don't, but it doesn't really matter. We're going to talk about it right now. And the idea of functions, y'all, when we're taking a function says that for every number that you plug in, so like we plugged in 0, we should get exactly 1 answer. We shouldn't be getting 2. Like if I told you, what's 3 squared? When you square 3, what number do you get? 9. You don't get anything else, you get 9, right? If I ask you, what's 7 squared? You don't get anything different, you just get that one answer. But here, do you see how we're coming up with 2 answers? We're coming up with 0, but we're also coming up with 2 pi, right? And so the idea here is, well, we shouldn't be getting 2 answers. We should always get 1. So when we look at functions, okay, and guys, I want you to see something else. Wouldn't another one of those answers, we came up with 0, and we came up with 2 pi, but wasn't this also another answer? Wouldn't pi have also been an answer, because the sine of pi is also 0? That's why I'm looking at my picture, right? Okay. So the idea says, in order for a function to have an inverse, the function has to be what we call 1-to-1, meaning that for every x number, there's only one y number, and for every y number, there's only one x number, okay? And so what we say is, looking at the picture, there's something called the horizontal line test. And the horizontal line test says if you draw a horizontal line, and if you hit the graph at more than one part, that function is not 1-to-1, and therefore it doesn't have an inverse. So if you notice here, they start drawing this horizontal line, and you can see we're hitting at a whole bunch of points, right? So the function doesn't necessarily have an inverse. But what we can do is we can say, well, you know what we're going to do? We are going to restrict the domain, meaning we're going to look at the function just between negative pi over 2 and pi over 2. Just looking at the function, just looking at that blue graph, doing this number from your perspective, right? Coming from the bottom, coming over here to the top. Between here, if you disregard all this other kind of business here, and we only look at this part right here, and I'm going to zoom in even more. That's about all I can zoom in. But all I want you to do is pay attention there. If I start drawing a horizontal line, how many times am I going to hit the graph? Just one. So the function has an inverse over the domain of negative pi over 2 and pi over 2. Okay? And I'm going to explain what that means. I'm going to show you how we're going to do some inverse stuff in a second. Okay? So this part earlier says, recall that a function has to be 1-to-1 to have an inverse function. That's that horizontal line test. Okay? So in order for us to have an inverse, function has to be 1-to-1. So what we do is we restrict the domain. And let's see. So we're going to restrict the domain. Here we go, between negative pi over 2 and pi over 2. And so that's exactly what this kind of picture over here is, because now we're only looking at this part of the graph. Okay. So guys, inverse sine function, there's 2 ways to write it. One of them is sine inverse, that's sine with the power -1. The other thing is arc sine. Arc sine and sine inverse mean exactly the same thing. Okay, there's no difference between the two, just 2 names for the same exact thing, right? Tomas, Tommy. We're talking about the same person. Okay, so what I want to do here is I got a table of values here, okay? So what we've done here is I've used table of values. I'm looking at values between negative pi over 2 and pi over 2, okay? And so what I have here is these special values, negative pi over 2, negative pi over 3, negative pi over 4, pi over 6, 0, pi over 6, pi over 4, pi over 3, pi over 2. Okay, so if you want to remember what they are in terms of degrees, remember, this here is going to be 90 degrees. Guys, think of pi as 180. What's 180 divided by 3? What's 18 divided by 3? 6. So this here would be 60. This one here would be 45. This one here would be 30, 0, 30, 45, 60, 90, and I forgot something. Those are negative, right? Because there's a negative. Okay, so guys, you're going to have access to this little chart as well, right? Sine inverse of -1/2. All that's asking me to do is come over here and say, when is the sine equal to negative 1/2? At what value? Negative pi over 6. That's all you're doing, right? So if I know what the sine of negative pi over 6 is, if I know what the sine of negative pi over 6 is, then I can find the sine inverse of negative 1/2, right? Okay, arc sine, remember arc sine, same thing as sine inverse. Arc sine of square root of 3 over 2, what is it going to be? And again, all I'm doing here, y'all, is just using that chart. Right? It's just helping me figure out what these values are. Okay, look at the third one. Sine inverse of 2. Huh? But so remember what the idea here is. I'm looking at these values here. So when we did this one here, we said, look, square root of 3 over 2, oh, that was that one right there. So our answer had to be pi over 3. So now I'm going to look at this part here. Do you see 2 on that bottom row? Okay, there you go. If it isn't there, y'all, it's going to be undefined. Okay, and that's all I'm really trying to do here. Okay, so let me scroll a little bit more. Guys, the same thing happens, like the way we had to restrict the domain for sine, the same thing happens with cosine, with tangent, things like that, okay? So for cosine, y'all, what we're doing, we're restricting the domain between 0 and pi. And for tangent, we're restricting the domain, again, between negative pi over 2 and pi over 2, but we are not including those numbers. Okay, we're not including them. That's why the little inequality signs here don't have the equal to, because we're saying here's negative pi over 2, here's pi over 2. We're just coming in a hair. Okay, we're not going to include those values. We're going to get really, really, really close to them, but we're not actually going to touch them, okay? For the sine and the cosine, we will. That's why we have the little equal to part. So look, I'm going to do the same type of process again. I got my tables here. And so all I'm going to do is I'm going to use these tables. So guys, the one thing I want to recommend is when you're doing your homework at home, what you really want to do, use the table. Okay, the table is going to help you tremendously in trying to do these types of problems. Okay, arctangent of 1. So remember, arctangent of 1 tells me the first thing I need to be looking at is this piece right here, okay? Because we're dealing with the arctangent. Anybody know what the arctangent of 1 is? Pi over 4. Okay. Let's do the same thing for the cosine inverse of negative 1/2. What is the inverse cosine of negative 1/2? 2 pi over 3, right? Because it's this one right here. See what I'm doing, John? Okay. Good, 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 good. And we got a couple more. Let me see if I can zoom out just a little bit so you guys can see a little bit better. I know it's a little crowded. That looks about right. Okay, our cosine of square root of 3 over 2. What's this one going to give us? Pi over 6. Good. And what about the inverse tangent of 0? Good. Got it. Easy breezy cover roll. Use the chart because it's telling you exactly the values that we're going to look for. Okay. All right. So now let's take a look at these next couple of problems we got here. It says use a calculator to approximate the function values in radians or degrees. Okay. So guys, what I'm going to do here, I'm going to grab my calculator because the problem is telling me to use my calculator. This is exactly what I want to do. Okay. So let me do this business right here. Well, so I'm actually going to do the problems with both because it says to do it in radians or degrees. So like if you look at problem number 11, it's actually asking me to do it in degree measure. But I want you to be able to know how to do both so that you can write the answer. Depending on what problem you have in your homework is, you can write it the way it's asking you to write it. Okay, so look, let me clear this out. I'm going to see what I'm in. We're in radian. Okay, so I'm going to do all these problems first, guys, in radian, and we'll go back and do it in degrees. Okay. So on your calculator, guys, has anybody downloaded that calculator app yet? No? So some of you have, some of you haven't. So You have your phone with you? Okay. What kind of phone do you have? iPhone, Android? iPhone. Okay, so what you're gonna do is, does anybody else need to get it? Anybody else need to download it? The calculator app? Well, that's just my regular calculator, right? I'm talking about the graphing, like the one when I send you guys the videos, the calculator app that I use. So guys, those, whether you have iPhone or Android, go to either Google Play or App Store, and what you're gonna type in, it used to be called, they used to misspell it, and I think they spell it right now. But this is what it's called. Graph and Calc 83. So, hello. Okay. Finally. And welcome to the last few days. Have a seat. Don't sit next to somebody. Okay, so Graph and Calc 83. Got it? Okay, I'll tell you what. Try that one. Try the next one we just calculated before. Those of you who have Android, do you all have to pay too? Anybody here have an Android? Did you have to pay for yours, or you already? Oh, you already got a calculator, so you don't need it. Okay. Huh? It's free on yours, and yours is Android. Okay, so Thomas, you might try to do that. Get what is it? Calculate 84, whatever it was. It should work the same way. It really shouldn't be any different. Okay. So on the Android, it's free. That kind of sucks that it's. You know what? Let me ask you one more thing. Those of you who have iPhones, this is how it used to be spelled, with an F instead of PH. If you type in that one with a, does it come up? You still got to pay? Because when I did mine, see, I got mine about a year ago. I did it like last fall, I think, or maybe I might have had it even before, but I think I did it last fall. And mine, when I yeah, that calculated 84, that should work. I think this is going to work. So I'm back here. Okay, because I have it on my iPad, and it's okay, because I have it on my iPad and on mine. When I downloaded it, they spelled it with an F, and that's what I've been using. But I want to say that I had the Calculate 84. Those of you who have the iPhones, I used that one before too. It should work pretty much the same way. But the reason I was telling you guys, like I know Jennifer has an actual calculator. If you have an actual calculator, that's great. You have what John has one too. You got one too. That's perfect. The reason I was saying the app is if you don't have a calculator, like did you check yours out or did you buy yours? It's a bar one. Okay, John, you bought. I'm sorry. You bought it in high school. Okay, guys, if you go run down to Target, Walmart, whatever, those calculators normally run about $100, right? Uh, the app, even if you get that one, it's $6. Compared to $100, I'd rather spend $6 because it's going to do exactly the same thing, right? And you can use it on your tests and all that kind of good stuff. The library does have calculators that you guys can check out if you want to do that as well. So you do have that option, okay? All right, so anywho, let's come back over here and let's see if we can't figure this thing out. So guys, remember we said we're in radians. So let me quit this here. And guys, whether you have the calculator 84 or whether you have the graphing calc, your calculator, the keyboard should look real similar to this. So if you hit the mode button, you should see whether or not you're in radian or degree. I think by default, you're probably going to be in radian. And then all I'm going to do is arc cosine just means I'm going to go second cosine, because arc cosine is the same thing as the cosine inverse. And look at the number we have here. What do we have here? Okay, so we're going to do exactly that, 3 over 5. And I'm going to hit enter. Okay, so guys, just to give you a heads up, on the homework, when we're doing it in radians, it's going to ask us to round to 4 decimal places. So let me ask you a question. To 4 decimal places, what number should I put? If I'm going to round to 4 decimal places, 0.9273, right? Good. So 0.9273, right? Okay. And we're going to do the same thing for the next one. We're going to do sine inverse. So I'm going to go sine inverse, so second sine, right, of negative 0.0457. And I'm going to hit enter. And did you guys come up with the same exact number? No? Okay, so maybe I did something wrong. Sine inverse of a negative point. Oh, that's what I did. I put a 0. There we go. Yeah, I put in a 0. Okay, so negative 0.4746. Are you in radians?
Yes.
You're in radians? And did you enter in sine inverse of negative 0.457? The what now? The first one you did wrong?
Yeah, I don't know why.
Did you put cosine inverse? Are you putting parentheses 3/5? And you're still in radians? Yeah. And then guys, we got one more to do. Arctangent of negative 2.09. So remember, arctangent, same thing, tangent inverse of negative 2.09. Enter this in. And again, I'm going to go to 4 decimal places, negative 1.1245. Okay. And so Thomas, are you using that calculator 84? It's working for you? Same thing, right? Okay, so calculator 84, guys, seems to work exactly the same way. And again, my whole reasoning for and guys, it's not that I don't want you to go, I don't want you to have an actual calculator. It's just that if you can get it for free, do it on your phone, right? Did it make? So again, even if you got the other app, right, the graphing calc on your iPhone, and you paid $6 compared to 145, but I also agree, hey, free is even better, right? Okay, so guys, hit the mode button, and we're going to change from radians to degrees. So I'm going to scroll down here. I'm going to select degree, and I'm going to hit enter. And so you want to make sure that the degree part is being highlighted, right? And then you can go ahead and quit. So just go second mode. And we're going to do exactly the same thing, except now we're going to be getting our answers in degrees. It's something we'll talk about that a little bit later. Let's go through these first. But yes, I'll get to your question soon. Okay, so arc cosine of 3/5, so 3 over 5. Again, guys, if over 5. If it doesn't do parentheses for you, make sure you do put them in parentheses, okay? Because if you don't do it in parentheses, it might do it as cosine inverse of 3, and then take that number and divide it by 5, and there is no cosine inverse of 3. Okay, so in terms of degrees, for degrees, guys, it's usually going to ask you to round to 1 decimal place. So this would be 53.1. Okay. And let's do the same thing over here. So sine inverse of negative 0.457. And I'm coming up with negative 27.2. Right, because we're rounding to 1 decimal place. Yeah. And then one more time, arctangent. So arctangent of negative 2.09 and negative 64.4. So John, did that first one work for you after a while?
Yeah, it's better when radians and like second degree, then break kind of actually.
It's working? Okay. Good. All right, so guys, we got another problem here, number 11, and saying use the calculator to approximate the degree measure. If you notice what it says here, 1 decimal place. Okay, so for the most part, in your homework, when it's asking you to use your inverse trig functions and it's asking you to do this for degrees, it's usually going to ask you to do it to 1 decimal place. Okay, so let's go ahead and do that. So we're going to go second sine inverse of 3/8, right? And 22.0 degrees. Okay, so guys, again, just to kind of give you a heads up, what am I doing here? My angle theta is going to be equal to the sine inverse of 3/8. Okay, sine inverse of 3/8. All right. So let's try the next piece here. Look at what it is we're trying to find. We're trying to find the arc sine of the sine of -pi/6. Let me ask you a question. Forget about that piece right now. If you were sitting at home and you had to find the sine of -pi/6, how would you do this? What would you do? Okay, you could say, let me use the chart, right? So I'm going to come back over here. And where's the sine one? Here we go. So we said the sine of -pi/6 is going to be equal to what number? -1/2. Okay. So I'd come back over here and we would say, now what we're trying to find is the arc sine of -1/2, right? Okay. And now if we're going to find the arc sine of -1/2, we would scroll back down, right? And I think I'm going to try to make this a little bit easier for you guys. The arc sine of -1/2 would then just be what number? -5/6, right? Okay. So my answer here would be -5/6. So I want you to look at the problem that we started off with, and I want to look at the answer that we came up with. Does it look like? It looks like that's what happened, right? It looks like that's what happened. I'm not saying that's what happened, but it looks like that's what happened. Okay. So look, let's do it like this. Let's do exactly what the Mas suggested we do with that problem. Let's do the same thing with this one over here. Okay. So the first thing we're going to do is we want to find the sine of 7/6. So guys, if I can, I'm going to do this, just so I don't have to keep scrolling back and forth. I want you to look at my chart here. Do you see 7/6 anywhere in this chart? No, neither do I. So I can't just necessarily say, you know what, let me cancel those pieces out, because as I'm looking here, I don't see that 7/6. Okay, but let me ask you a question. Again, forget about this part. If you were being asked to find the sine of 7/6, let me ask you a question. Are you guys more comfortable with radians, or are you more comfortable with degrees? Some of you are more comfortable with radians. So there's a couple of ways we could do this, right? So this is what I want to do. I'm going to show you two ways, and I'm going to ask you which way you think is easier. Suppose you said, I'm more comfortable in degrees. And if I wanted to convert 7/6 to degrees, y'all remember this is how I'm going to do it? I'm going to multiply by 180 over pi. And so wouldn't we, remember this is 180 degrees, right? And then wouldn't we say, look, let's cancel this pi here with that pi right there. And 6 is going to go into 80, what, 30 times? And 7 times 30 is? What's 7 times 3? There you go. You got it. Okay. Now, I want you to think about 210 degrees. Okay. So guys, remember, this is 0 degrees, 90 degrees, 180 degrees, 270 degrees, back to 360, right? 210, 210 would be somewhere right here. Okay? That would be 210. And we did this, it was probably in 4.4, but that was some of the stuff that you guys were doing by your lonesomes at home. We're going to find what we call the reference angle. We usually call it theta prime. And the way we find theta prime is we're going to take that whole thing, 210 minus 180, because it's always going to be with the x-axis, okay? So what's 210 minus 180? 30, okay? So this here is the same thing as 30 degrees, right? So in a 30, 60, 90 triangle, guys, this side here is 1, this side here is 2, this side here is the square root of 3, okay? So the sine of this angle is going to be the opposite over the hypotenuse. So the sine of theta prime would be 1 over 2, but what quadrant are we in over here? Remember, we have quadrants 1, we got 2, 3, and 4. Okay, remember how we defined the sine? We said the sine was always y over the radius, right? Y over r. A lot of times in a unit circle, we would just put y because the radius is 1. But in quadrant 3, is my y value positive or negative? So the sine of 210 is actually going to be a negative 1/2, right? So what I'm going to do is I'm going to come back over here, and I'm going to say, well, we were able to figure out what this is, and we came up with a negative 1 over 2. Okay? And now what I can do is I can say, well, look, now that we know that the sine of pi over 6 is negative 1/2, we can say, can I use that to find the arc sine of negative 1/2? And if I come back to, here we go, negative 1/2, look right here, guys, negative 1/2 right here in the middle. What's the sign? Negative pi over 6, right? So my answer here is going to be a negative pi over 6. So to answer John's question, can we just do that? Not really, right? We really can't do that because it's not always going to work. Because remember, we have been restricting the domain for our inverse sine between negative pi over 2 and pi over 2, okay? So the other way you could do this, y'all, is, let me grab my calculator here, and I'm going to try something here with you guys. Okay, so I want to make sure I am in radians. I'm going to come back to mode. I'm going to click on radian, okay, and I'm going to click this now. So I'm going to say, what is the sine of, what was it, 7 pi over 6? Okay, and look what we came up with. Negative 0.5. Is it negative 0.5? The second is negative 1/2. Okay. And then, and the reason why, and guys, what I don't necessarily want to do is, I don't want to necessarily do this. Look, I don't want to necessarily say now, okay, let me take the sine inverse of that answer, the negative 0.5, because look what it's going to give me. What number is that? That's negative pi over 6. But why do we know that? Because we just did the problem. But my point, though, is if we didn't know that the answer was negative pi over 6, not a lot of people would say, oh, did you know that negative 0.523598 is the same thing as pi over 6? Nobody would really say that, right? But we know what the answer is now. But if I came up with this answer, I know that's the same thing as negative 1/2, and then I can go back and use my table. Does that make sense? Okay. So guys, what I'm really trying to do in doing these problems is I'm trying to give you all the easiest explanation of how to do it. Who said they were more comfortable with radians? I know somebody said they were. You're more comfortable with radians? So do it with radians, okay? I think a lot of people are more comfortable with degrees just because you can think of the triangle, you can think of the y over r, the x over r, using that right triangle definitions of trig functions. It makes it, for a lot of people, a little bit easier to do, okay? All right, so look, let's try the same thing with the next problem, okay? We have the cosine inverse of cosine of 7 pi over 6. Okay, so let's see if we can't figure this problem out and see what we come up with. So cosine of 7 pi over 6. Hold on, we just did 7 pi over 6. Okay, so I'm coming back to my picture because I already have it drawn here. So remember what the cosine is. The way we define the cosine of our angle is going to be the x over r, right? Okay. So here's the x value over the r value, or we can say it's the adjacent over the hypotenuse, right? So I'm coming up with square root of 3 over 2. But again, what quadrant are we in? Quadrant 3. Is the x value positive or negative in quadrant 3? It's negative. So my answer here, guys, is really going to be a negative square root of 3 over 2. Okay. So let's come back over here. And we're going to say this happens to be the same thing as, come on, pen, the cosine inverse of the negative square root of 3 over 2. So that now, when I look at my cosine inverse, let me scroll over here so I can get to it so we can see it. Here we go. Negative square root of 3 over 2. What number are we coming up with? 5 pi over 6, right? Boom. Right? So remember that cosine and cosine inverse, I can't just say, let me cancel those things out. It's not always, it might work out that way like it did in the first problem, but it won't always work out that way. Okay. All right. And so guys, I put these little asterisks here as a note to myself saying, hey, listen, when I get to those problems and I show them to you guys, we can't just say, hey, look, let's just cancel them out. That's how it always works out. It doesn't really work out that way. Okay. Now for the next one here, guys, I'm going to go ahead and use my calculator again. Okay. Now look what we're finding first. We're finding the cosine of negative 1/2. So guys, unless it tells me to use degrees, I always have to use radians. Okay. So I'm going to turn this thing on again. All right, clear. I want to make sure I'm in radians. Yeah, we're in radians. Okay. So let's first find the cosine of negative 1/2. Negative 1/2 cosine is, okay, so now I'm coming up with the cosine inverse of all that business there. What was it? 87758 and a whole bunch of other business, right? Okay, now I want to find the cosine inverse of that. So now I'm going to go ahead and just use my calculator. I'm going to go cosine inverse. And instead of me typing out or putting certain numbers, because if I do that, then I'm rounding. And I don't want to necessarily round yet. So I'm going to go second in my answer. So it'll use the answer from the previous part. Hit enter. And what number are we coming up with here? 1/2. Again, not exactly saying, hey, let's just cancel those two things, right? All right. So for the next part right here, it says find the exact value. Okay, tangent inverse of -1 plus the tangent inverse of the square root of 3. So y'all, just like we did before, I'm going to use my table, right? Oops. I'm going to use this table right here. Okay, so the first part said tangent inverse of -1. What's the inverse tangent of -1? Negative pi over 4, right? Because we got that, sorry, we got that right here. So we're going to put negative pi over 4 plus, what about tangent inverse of the square root of 3? Pi over 3. Okay. All right. Question, what's the common denominator here? Well, good. We got to multiply this one by 3 and this one by 3. We got to multiply this one by 4 and that one by 4. So that's a negative 3 pi plus 4 pi all over 12. I'll give you a hint. The answer is going to be over 12. What's negative 3 pi plus 4 pi? There you go. What do you guys think? So far, we doing okay? John, we're good? Javier, we're okay? Just checking. Luciano? Is that what your name is? Okay, just making sure. Good, good, good. Okay. So guys, let's take a look at these next two problems. Similar type problems. The first one says, the directions say use the calculator to approximate the degree measure to 1 decimal place or radian measure to 4 decimal places of the angle theta subject to the given conditions. When I look at the first problem, do you think I want my answer in degrees or radians? Look at the conditions of the in degrees, because it's telling us that theta is going to be between 180 and what? 270. So that should give you the idea that that one's going to be in degrees, right? If you look at the bottom one, theta is going to be between pi and 3 pi over 2, so that one's telling you that one should be in radians, right? So when you think about this one, when you see the pi, radians. If it just has big numbers like 90s and 180s and 270s and 360s, degrees, right? All righty. So remember how we're going to do this now, y'all. We're going to, the way we're going to find our angle from here, we're going to say theta is equal to the cosine inverse, or the arc cosine, however you want to write it. It's the same thing, of negative 5 pi over, or negative 5 over 6. All right, so I got to make sure I'm in degrees. And we are, okay. And now I'm going to say cosine inverse of negative 5 over 6. And to 1 decimal place, 146.4. All right. And then let's take a look at the next one here. Let's see. Cosine inverse of negative 5 over 8. So again, theta is going to be equal to the cosine inverse of negative 5 over 8. So let me do this real quick. Okay. Cosine inverse, negative 5 over 8. And I'm coming up with, to 4 decimal places, 2.2459. All right. So let's take a look here, y'all, at this next problem here. And it says, a balloon advertised in an open house is stabilized by 2 cables of lengths 20 feet and 40 feet tethered to the ground. If the perpendicular distance from the balloon to the ground is 10 square root of 3 feet, what is the degree measure of each angle of the angle each cable makes with the ground, round to the nearest tenth of the degree if necessary? Okay. So the angles that we're looking for are this one here. I'm going to call that one theta 1. I'm going to call that one theta 2. Okay. So I'm going to zoom in a little bit here, guys, so we can kind of take a look at what's happening. So here is our first triangle. Let me do this in red. Okay. All right. So here's my first triangle. Everybody agree that this side here is my hypotenuse? Compared to the angle theta 1, would this side be the opposite or the adjacent? The opposite. Okay. What trig function involves opposite? There you go. So we would know that the sine of theta 1 is equal to 10 square root of 3 over 20, right? And so if we wanted to find our theta 1, we would say theta 1 is going to be equal to the inverse sine of 10 square root of 3 over 20. Because that's the side right here. And so guys, all I'm going to do now is grab my calculator. First thing I'm going to do, make sure I'm in, oops, make sure I'm in degrees because it's telling me to use degrees, okay? All right, so we're going to find the arc sine or the sine inverse. And guys, I'm going to enter it exactly as I see it. I see 10. I see the square root of 3. Okay. Now, I don't know if this does this on your app or on your calculator, but mine opens up a parenthesis. So I got to make sure I close that off. Okay. And then I'm dividing it by what number? 20. And all of that is my angle, right? So I got to close that, or that's all of that is my value. So I got to close that off so I can find the angle. And 60 degrees. Okay. All right. We're going to do the same exact thing for the second part, right? Okay, so let's do this. So I'm going to draw my picture again. I'm going to look at my picture here. Guys, am I going to use the same trig function that we used before? Same exact one, right? Okay. So we're going to say the sine of theta 2 is equal to 10 square root of 3 all over 40, which tells me that theta 2 is going to be the inverse sine of 10 square root of 3 over 40, right? And just like we did earlier, check this out. I'm going to go second, sine inverse, and I'm going to type in exactly what I see, which is 10 square root of 3, close off those little parentheses, divided by a 40, close it off again. And are you coming up with 25.7?
Yeah.
There you go. And you got it, Julian? What do you think? Sounds good? Not too difficult to do. That table really helps out a lot, right? Having that chart makes it easy for me to do. As long as I can use my chart, guys, I can do it. And then, like I said before, when you do come up with a problem like, what was it? Like these right here, you can either use your calculator keeping it in radians, or you can draw a picture so you can figure out what it is in degrees. And the one thing I do like about the picture, guys, is it helps me remember, in terms of a right triangle, how do I define the sine? Oh, it's the y over the r, or it's the opposite of the hypotenuse. Oh, what quadrant I'm in? Oh, I'm in quadrant 3, so I should know that my answer should be negative. Stuff like that. Obviously, if you use your calculator, you're going to come up with those exact values. Again, the only issue is when you're using your calculator and you're going to do the arc sine of -1/2, you're going to come up with some rowdy old decimal. Whereas if you use the table, it usually works out pretty nice and neat. And then I was going to show you guys something too. Let me see. I want to see. So guys, this is just a real straightforward, not even a graphing calculator. It's just a, what's going to call it? Just a scientific calculator. Let me see if I can figure this out. Go. I'm in radians. And I want to try something real quick. Second sine inverse of -1/2. Yeah. So I'm going to see if I'm going to do this real quick because I don't need that. But well, but I'm going to just pass it down. You guys can take a look. Just take a look at it real quick and pass it down. So guys, I just did this on, and this is the Casio, and I don't have a lot of experience with Casios, but I just typed in inverse sine of -1/2, and that calculator wrote it, gave me back the answer as -1/6 pi, which is the same thing as -pi/6, right? So if you guys kind of take a look, I'll let you guys have one. a look at it, it actually gives me that exact answer, right? As opposed to remember when I did my calculator and gave you that negative 0.52 and I had a bunch of that other stuff. I don't know, that calculator probably cost me like $11 or something like that. So if you got an extra $11 running around in your pocket and you maybe want something like that, it might be worth it to you. Maybe it is, maybe it isn't. I'll let you guys decide on that. But just wanted to let you know that, and I don't know, does anybody here have a Casio calculator? Some of you do? Okay. So if you have a Casio calculator, it may give you that, it may give you those real nice, pretty numbers like that. I don't have a whole lot of experience with the graphing calculators from Casio. The ones that I have a little more experience are the TIs. But, you know, if you got questions on, you know, how do I do this on my calculator, I'm more than happy to see if I can help you figure it out. But I hope you have some knowledge of it already. Anyway, guys, it's kind of a short day today. That was 4.7. So just to give you a heads up, let me do this real quick. Let me see. First thing I'll do is come back over here. I'm going to go ahead and stop recording this.